Welcome to Chapter 7, Ionic Equilibria. Now we are going to learn how to perform calculations involving pH, dissociation constant, initial concentration and equilibrium concentration, degree of dissociation. This part is almost similar to Chapter 6, Chemical Equilibrium, except for pH. Now, let's start with one example. First, calculate the pH of 0.1 molar acetic acid. Acetic acid CH3COOH, and then given Ka. Okay, we solve the first part first. Okay, so when we look at Ka, equilibrium constant for acid dissociation constant. So we write down CH3COOH, the plus H2O, then we will get CH3COO. Okay, remember acid donate proton. Then another one accept proton base. So this is the product. This is the reactant. So we substitute into the acid dissociation constant product over reactant. Okay, so the same thing. 0.1 here represents the initial concentration. Okay, so remember to build the ice table. Okay, and then we are given Ka. Then we fill in the ice table first. Okay, just like chemical equilibrium. Now, we are going to solve X. Okay, we want to solve X because we want to calculate pH equals to negative log H plus. Okay, however, this time we have additional step, that is assumption. Since Ka is small, so we assume that X is small. Thus, 0.1 minus X also equals to 0.1. Okay, what does this mean? Okay, why do we assume like this? Because, for example, if you have 0.1 minus 0.00001, your answer will be still equals to 0.1. Thus, we make assumption straight away, so we do not use the quadratic to calculate. And then this one will give you 1 mark because you know how to make the assumption. Okay, and then after you get the X, means you know the hydronium ion concentration, then substitute into pH equals to negative log H3O plus, then you will get the pH for acetic acid. Okay, another one is calculates the degree of dissociation. Again, same thing, degree of dissociation, we are looking for change over initial. Okay, so just now we have find our X, so we just need to substitute into the formula, but times 100 because ask for percentage, and then we will get our answer. And then you can see the percentage of dissociation is quite small, therefore it is a weak base. Weak acid. Okay, another one. Ethylamine is a weak base. Okay, asked to calculate the pH. Okay, and then given the base dissociation constant, okay, this time is negative 4. It is not negative 5. Okay, so the same thing again. Rewrite the equation and then put in the ice table. Fill up the ice table. 0.15 is the initial. Okay, same thing. If we want to know the pH, but this is a base, so we know that POH equals to 14 minus pH. Okay, so from here we can find POH first. Okay, so solving X will lead us to POH. Okay, however, this time, why are we using quadratic instead of assumption? Okay, because just now I mentioned Kb given is 10 to the power of negative 4. Okay, so we cannot ignore that it might give it might means that 0.15 minus x is not equals exactly to 0.15. Therefore, we need to use quadratic. Okay, when we use quadratic, we have two values. One is negative here, one is positive. Okay, so why do we choose the positive one? Okay, because you must understand, if you choose the okay, let's say if you choose the negative, means that 0.15 minus 9.45 times 10 to the power of 3. So you will be getting a value more than 0.15, which is larger than the initial. So it doesn't make sense because initial must be more than the equilibrium for reactant. Therefore, we choose 8.88. Okay, then again, same thing. In order to find pH, we use pH plus pOH equals to negative 14. Okay, so now I just want to highlight again. Remember, if it's 10 to the power of negative 4, we do not use assumption. Okay, but if we have 10 to the power of negative 5, 10 to the power of negative 6, 10 to the power of negative 7, and so on, then we can use assume the value is very small. Okay, now next one. Okay, this time we calculate Ka. Okay, same thing again. Remember Ka, the term is dissociation constant. Build the ice table, okay, and then substitute all the information inside. Now, let us see what is given. What else is given? Another one is pH is given. pH given means that we will know the concentration of H3O plus. Okay, so if we look at here, pH equals to negative log H3O plus equals to 5.1. Therefore, H plus equals to 7.94. So this one is the X. Okay, then after that we can start to find Ka. So substitute the value inside, then we will get Ka. Okay, now next one, calculate the equilibrium concentration. Okay, means that we want to know at equilibrium what is the concentration. Okay, same thing again. If it doesn't give you any equation, then you have to write on your own. And then you can see here the given Ka is 10 to the power of negative 5. Means you can do assumption that Ka is very small. Okay, so let's substitute. Write the Ka first, expression. Okay, remember the ice table. Then finally, what do we want to find? We want to find the equilibrium concentration for acetic acid. Okay, so we want to find this part. So after you solve for X, you will get the final answer. And don't forget your unit. Okay, now next. Then remember, don't forget the assumption. Okay, because this one will give you 1 mark. Okay, now next one. Calculate this time is initial concentration. Same thing, build the ice table. Okay, so we are given pH, but remember this one will be pOH, not pH. So we use pH plus pOH equals to 14. So when we can find the concentration of OH minus, means that the concentration is representing X. Okay, then after that, in order to find the initial concentration of ammonia, okay, we also need to use quadratic to solve the problem. Okay, no need quadratic because we have 10 to the power of negative 5, which is very small. Okay, now I will highlight again what is important. Okay. So remember, if the Ka or Kb given is 10 to the power of -2, 10 to the power of -3, 10 to the power of -4, we cannot do assumption. We must use quadratic. Okay, if let's say it is -5, -6, -7, then we can use assumption. Just like this. Okay, since Ka is very small, we assume that x is also small. Thus, 0.1 minus x equals to 0.1. The calculation for this part is not difficult because it is similar to chapter 6, chemical equilibrium, where you always start with writing the expression for Ka, equilibrium constant, or this time we say acid dissociation constant. Another one, write the reversible reaction equation for the weak acid or weak base. Then third one, we build ice table. Then after we build ice table, we find X, okay, initial or at equilibrium. Okay, but only specially for Ka, if it's very small, if it's -5 and so on, we make assumption. Okay, so that's all for this part.